That's the reason why Perl got a much higher profile, because it was used for making web pages do something more than just show you what you put in the web page. But another piece to it is that Gartner believes, and believes deep in their hearts. I say this after many, many years of talking to these people. They believe that if it's hot, they don't want it. And the reason that if it's hot, they don't want it is because they believe that people in corporate IT shops, who are the folks they talk to and sell their $1,500 reports to, don't want it if it's hot. It's hot, it's too edgy. They don't want to be on the cutting edge. They don't even want to be anywhere near the edge, because if you're near the edge, you can fall off. So, all of a sudden, after 20 years, something like that, small languages that didn't exist before because there wasn't really the processor power to do much of anything interesting with a small language. And then processing power arrived and started doing that stuff. 20 years later, it becomes something that mainstream IT, mega vendors, the big boys, are interested in. What will they do with this stuff? Well, they may actually use some of it for things that it was intended for, like Cisco is. They'll also use it for some other things that are talking about the next generation application development efforts. I love this. If you're going to glue things together, if you're no longer going to build big systems in an IT shop, if you have a big budget, you're going to spend it on SAP, and you don't want to have to tear up an SAP like everybody did for the first couple of generations of these projects. You want to just glue things together if you can. It gets even worse when you get into things like cloud computing, where you not only don't want to tear open the lid, you can't tear open the lid because they've sold you the product and you don't get to get the product, you just get to talk to the product long distance over the phone. That means you need more languages that can do that, things that can glue stuff together. Very important piece of what's going to happen with small languages. But that's still really not the future. For the people in IT shops, for Gartner, for the big vendors, that's disruptive. Which is sort of the key point about what future is. The people at the Microsoft Professional Developers Conference were all smart people, and they were talking about things like better concurrency and better security, and there's nothing really new about any of those ideas. Everybody knows about how an engineer predicts the future. He does it with a straight edge and semi-log graph paper. You plot a few points, draw the line, and that's what the future looks like. It's just like the present, only more so. But that's not the future. The future is only the future if it's disruptive. Something breaks that line. Something changes the way people do things and think about things. 1979 is the future that I was talking about before, 30 years ago. Actually, 1978. An MBA student in Harvard Business School was riding his bicycle on Martha's Vineyard, which immediately tells you that he was not a poor MBA student at Harvard Business School. And he was daydreaming, which apparently tells you that he was a well-insured MBA student at Harvard Business School. His idea of technology he could use was the time-sharing system or his TI business calculator. And his daydreams included the possibility, he was interested in technology, he had seen this mouse thing that Doug Engelbart was pushing as an idea for how to control a pointer on a screen. 1979, remember, this is Xerox Aldo time, a little well before the Macintosh. And so he'd seen that, and his idea was to put a mouse ball on the bottom of his calculator. That way he'd be able to move the calculator around and punch numbers in. And then, this is the part that was really great, a heads-up display, fighter pilot kind of thing. So he could move the mouse around, punch in numbers, and maybe circle a bunch of numbers, and push a button, have them all add up. It was a great idea. He was not that much of a techie. He could figure out how to do a little bit of programming. He tried to prototype it on the time-sharing system, and it did not work very well. He borrowed an Apple II and was able to prototype it in BASIC. And that was pretty much the point at which, when he tried to prototype it on the time-sharing system, that's where the heads-up display kind of went away. That was not really available. And for that matter, that was where the mouse went away too, or the mouse ball on the bottom of the calculator went away. He had an idea that got scaled back and scaled back. And he realized that he was making all these notes on the back of ledger paper. Okay? That's a metaphor, sort of, that'll work. It's not really much of a metaphor. It's exactly what you do. You write a bunch of numbers and add up the column. And you would get the thing to do it for it. So he made this prototype of this program called CalcuLedger, he called it. And he could get it to work. He showed it to some friends, and they thought there might be a market for this. In fact, everybody who saw it that was in the MBA program with him at Harvard Business School thought this was really interesting. Virtually nobody else did, but they all thought it was interesting. And so a guy who graduated the year before and started a little consulting company said, okay, I think we can probably turn this into, the guy he borrowed the Apple II from, said, I think we can probably sell a few copies of this. So they decided to price it about the same as that TI business calculator cost, about 35 bucks. And CalcuLedger was going to be this wonderful product. And it was introduced, they fixed the name. It was the first spreadsheet program that was widely sold. It was VisiCalc. Well, VisiCalc eventually was replaced, supplanted, pushed out, killed, beaten to death by Lotus 23, which in turn was supplanted, beaten to death by Microsoft Excel today. But it's still the same basic idea. It is programming without programmers. If you think it's not programming, think about what a spreadsheet would look like if you took away the user interface. A1 equals sum, colon, B1, sum, parenthesis, B1, colon, B6, parenthesis close. A2 equals whatever. That's not a procedural programming language, but that's programming. That's something that nobody thought of as a small, it's certainly a small language. Nobody thought of it as a small language at the time because the language was too small. It was so small, so simple, you never did anything more than type things into a single cell. Well, it's gotten more complicated, and there are now control statements, and you can do automation that does all sorts of things again and again and again and again and again. But it's still a small language. And yet, the people who program, there are programmers who really get irritated at having to do spreadsheets, having to work up spreadsheets. Most people who work up spreadsheets are not programmers. They don't think of themselves as programmers. They're not doing programming. They're just doing spreadsheets. That's disruptive. That's a future. Everybody's got a cell phone, correct? Everybody have a cell phone? Somebody doesn't have a cell phone. Thank God we've got somebody who doesn't have a cell phone. Right? So I've got the tie, he doesn't have the cell phone. How many people here who have cell phones have a contract? Show of hands.
Have a contract.
Have a contract with a phone company. So how many people here do not have a contract with a cell phone company? 1, 2, 3, 4, 5, small number of people. I don't have a contract with a cell phone company. I have a pay-as-you-go phone. And it wasn't until I got that pay-as-you-go phone that I realized how disruptive this thing is. 50 years ago, suppose somebody from 50 years ago falls asleep, does a rip down window for 50 years, wakes up today and is walking down the street. what's the thing that person is most likely to notice?
Google those cell phones.
Cell phone. The clothes aren't that different. You know, yes, there's kids with piercings and, you know, funny hair and all of that, but fashion comes and fashion goes. People are still driving cars. People are still walking down the street. The cell phone, that's different. But the cell phone is still not radically disruptive. It's smaller than a walkie-talkie. It is smaller than the portable phone that rich guys used to have. We only saw them in movies, but you know, car phones, things like that. But it's still unexpected. But even that's not disruptive in a big sense. It's disruptive in a technical sense. You know, people can carry their phones with them like they have an invisible extension cord. But 50 years ago, if you wanted a phone, you called the phone company. Well, you contacted the phone company, and you give them a bunch of information, and they issue a phone, and they connect to it. 50 years later, if you want a phone, most of the people in this room went to a phone company, gave them a bunch of information, signed a contract just like 50 years ago, and got phone service. This is a phone that I paid money to a guy at a convenience store, and he sells me a card. Now that money goes to T-Mobile in this particular case. But T-Mobile doesn't know who I am. I paid cash for the cell phone. And so the guy at Kmart didn't know who I was. I can pay cash for those cards, and the guy at the convenience store doesn't know who I am. For the first time in the 100+ years of telephony, it is possible for anybody who's got $30 cash in his pocket to have a phone number. A real phone number that the phone company doesn't know about you. It's a completely anonymous phone number. That's disruptive. That's the future. That's something that is completely different from the past. You're not a little bit farther along that straight line on singular graph paper. That's disruptive. So, when you get something that breaks the model of the future, the straight line singular graph paper, that kind of thing, that's when you get to real futures. Not just futures that look the same as they were 50 years ago, except for one little thing. And remember, that one little thing that's different is completely surrounded by stuff that's virtually the same. We're still speaking the same language. We haven't gone to whatever this relationship between modern English and Middle English. We haven't gone. You know, I think that will take thousands of years to happen as it happens. We haven't started wearing. We don't have blind bars. Damn, we don't have blind bars. We don't have most of this stuff we like to think we ought to have. It's just not there. One of my favorite little clips on the one Walt Disney's Wonderful World of Color was what it was called at the time. Where I first saw this, it was a clip from the 1939 World's Fair in Chicago. A little presentation that they did about the future. It was the world of 1960. They had the flying cars. They had the pristine streets and no traffic jams, and everything was skyscrapers. None of that stuff happened. The real breaks that happen are they depend the future to be a recognizable future. It depends on those discontinuities. That's where the hard part about talking about the real future of small languages comes. There will be some things, like Cisco, that will show up in places that you won't even see it. You have a language like Tickle. There will be other places where large organizations will use small languages to glue stuff together to be able to talk to the cloud. But they won't be doing it for the small language. they'll be doing it for the cloud. Just as you don't go to Cisco for Tickle, you go to Cisco for networking function. What I've been trying to think of, and I've been unsuccessful, fairly spectacularly unsuccessful, in coming up with, is what's like a spreadsheet. The spreadsheet was disruptive. Completely changed the way people did your taxes, for example. You no longer need a genius tax preparer to get the best possible tax return. You go to a mediocre tax preparer, who types all the information into a spreadsheet, pushes a button, and walks away. And the PC grinds through every possible combination of the numbers you've given it and comes up with the one that minimizes your tax bill. That's disruptive. It lets, like most automation, it lets people who aren't as good do the same things it used to require somebody who's much better. But a spreadsheet is also different because, as I said, it's programming without programmers. And I finally realized that the reason I couldn't come up with some great examples of what these futures could be like is that it depends on somebody who's not thinking in terms of programming. It depends on somebody who's thinking like, and my brain's gone blank, I can't remember his name. Who was it who came up with the idea for VisiCalc? No, that was Lotus 123.
Dan Bricklin.
Dan Bricklin, thank you. Dan Bricklin was that student bicycling on Martha's Vineyard. Why Dan Bricklin was able to come up with that, of course, was because he was steeped in spreadsheets. He was at Harvard Business School. He was thinking in terms of these things. And that was the way he thought about this stuff. Chances are we're not going to come up with these real disruptive futures. But we are the people who are ultimately going to make use of the small languages that show up to push things along. And we're going to be the people who will be most likely to see those futures when they show up. And I really wanted to be able to come up with some of those examples. And I didn't come up with any good examples. I didn't even come up with any bad examples. So I guess my question and my challenge to you guys is, how can you do what a small language does in a way that breaks the way we think about small languages? There are a bunch of people here who are programming without programmers. Everybody, almost not everybody, but many people here, or more people here, are doing programming without being programmers on your job description. How do you spot that future? How do you get to the automation that makes it possible for more people to do what small languages make it possible for you to do in your job, what Tickle makes it possible for you to do in your job, without being a full-fledged, full-blown programmer? I don't know the answer to that, but I think this is a set of things to think about in terms of where that future is going to go. And in the meantime, we are going to see more use of small languages in IT jobs. Why? Because Gartner has said we will. And once you pay $1,500 or $2,500 for a Gartner report, by God, you know that's good advice because you paid good money for it. We are going to see more use of it in terms of cloud computing. We're going to see it embedded into, when Gartner tells them, when Gartner says, in fairness, when Gartner says that the mega vendors will begin supporting this stuff around 2011, that means that Gartner has heard from those mega vendors that yes, they plan to support various kinds of smaller scripting languages or dynamic languages, starting around 2011. There's very little in the prediction business, if you're a company like Gartner, that actually involves making guesses. Most of Gartner's predictions are actually what people who are on the front end of the curve are doing right now. So that's the short-term future, which we can easily describe because it's not a guess. A longer-term future, the important future, the disruptive future, we don't know, but we can watch for it. And that's the end of, as will often happen, either I will run long or I will run a little bit short. But anybody have ideas? Do we have the next spreadsheet? And can I have this? Yeah.
I think that one of the things that's made these programming languages successful is a relatively confined application. There are other examples that you can point to, Latin, hypercard, things like that. I think what the big discontinuity would be to be able to do that in a general case, right? The people that are sticking their foot in the water and executing in UML, maybe fighting off that chunk.
And the question is whether it will ultimately, I think part of the question is whether it will ultimately be possible to, because of course the spreadsheet is exactly that very domain-specific thing. Although an interesting thing did happen. When I first started watching people buy things like the Osborne One, these PCs that had a whole bunch of programs bundled in with them. Well, most of the people I knew were professional writers. And so they knew what to do with a word processing program, or they figured out what to do with a word processing program. This spreadsheet thing, most reporters are lucky if they can balance their checkbook. With or without a spreadsheet, the whole concept of balancing the checkbook is difficult. And so one writer I know, he didn't actually have any, he wasn't going to use it for personal finance or anything because he didn't make any money being a writer. But he used it as, he figured out how to create a spreadsheet that was 7 columns wide, and he used it as a calendaring application. I've seen people do a lot of schedules because it gives you nice, neat, it's a very easy way to do it. Like most programming languages, you can use this for all sorts of ridiculous things. You can use a spreadsheet to test state machine designs. All kinds of things that it's not designed for, which maybe that does raise a question of how limited to a domain is some of this stuff. Maybe I'm thinking in terms of spreadsheets too narrowly, because if people really are using them for playing around with state machine, you use the technology that you have. I remember, I have a vivid memory of it because it was so striking to me. Before he discovered Pickle, Cliff Flint was a Fortran programmer. In this big way, Cliff was a Fortran programmer.
I'm Cliff Flint. I was Fortran programmer.
I am a Fortran programmer.
You're not supposed to say Cliff Flint. You're supposed to say, I'm Cliff.
Oh.
We all say,
Hi, Cliff.
there's not a lot of folks members here.
Talk to Ian, he is a Fortran programmer.
Cliff once proudly announced to me many years ago that he was almost finished with this program that would allow him to print out transcriptions of music written entirely in Fortran. I pointed out, but Fortran is not necessarily the optimal language for doing this in. He said, yes, but that's what I program in. People who use spreadsheets, and they do, it's the tool they have at hand. And that may be the reason, that may be ultimately where, it may be that the spreadsheet is the last piece of this future. Everything else will be a variation on spreadsheets. It may be there's something else that's better to do it. It's the same kind of thing. It's the, people keep trying to do this. They think of them as modeling tools, but the truth is once you start writing things like A1 equals some parenthesis B1 colon B6 parenthesis close, that's programming. It remains programming in one way or another. Ideas, responses. Yes.
Oh, one area I've been noticing a lot more of is programs, writing other programs. We're finding that, a lot of the things we used to have to do by hand, now somebody writes an automation that writes an automation that writes, and it's getting to the point where, I just have an idea. And the path between the idea and actually having something that is on my desk and bouncing is getting shorter and shorter as we go. It's almost to the point where, with just a little less knowledge, somebody else could do it without the 15 years and haven't been there.
And that's in what domain area?
Rapid software prototype.
No, I mean, but specifically, are you talking about this in terms of personal experience? What's your domain area?
Right now, I'm modeling human behavior.
You can actually get like business rules or logic that will accurately model human behavior.
For small values of accurate, yes.
Okay, as long as we have special values of accuracy. Yeah, that's when you stack things up. At a certain point, you still have to have some way of describing the model. How do you describe the model? Maybe the modeling that we're talking about, and I think my dad's an architect, the kind who puts up buildings, not the kind who is a software architect who runs projects. And this was back in the days when you had 4H pencils. Nobody here knows what a 4H pencil is. 4H pencil is a very hard. Oh, you knew what a 4H pencil is. Thank God, a couple of people know. We have really old people.
I would have one of those. I would have one of those and a rapidograph in my pocket protector.
Yep. So we can geek out on the old days, because I was a draftsman at one point back in the days when CAD, what's that? But you draw a building, and then you have to do all of the stuff that goes underneath the building. In theory, it should be possible to draw the model of the building, and in fact, today it's possible to have a lot of that stuff generated. Still tweak, you still have to fix. But for that first rough draft, and if all you're putting up is something simple, maybe we are getting a lot closer to, and maybe there are actually a lot more domain areas than I realized, where what once would have required programming now involves stuff generating stuff. Maybe we have, maybe we're not just another 10 or 20 years farther away from 1979. Yes, sir.
Yeah, the example I use when I'm saying a similar thing is TiVo and the all of the PVRs. You're scheduling. My wife goes through, she doesn't program, but she schedules the entire season for what she's going to record at what time, what place, which channel, change here, change there.
People with a TiVo sitting next to an old VCR that's going blink, or DVD recorder that's still blinking above the clock.
Yeah.
Can't program the time, but can do what they don't think of as programming for TiVo.
Program capturing program.
Yeah.
The difference between the VCR and the TiVo, or between a regular programming language and the spreadsheet, I think is the same thing. The model is visible. To program the VCR, you have to have a model in your head of what that VCR is going to do and how it's going to work. And then you got to manipulate the buttons to manipulate that mental model. With the TiVo, it's all on the screen.
And you don't get access to the underlying code. Just as with a spreadsheet, you don't get access to you don't write this long stream of one-line cell contents. You just do it through the interface. Maybe that's where we're going to be going. But because real futures are disruptive, as I say, it ain't the future until something breaks. Maybe I'm completely wrong about that. Yeah.
So at the risk of ranting, talking about discontinuity, my sense of why there isn't a disruptive future is that we're living in a sort of medieval, balkanized media land, where we all have these 4 or 5 devices in every family or even every individual that all have different pieces of your life, different pieces of media, and 20 or 30 websites that you may go to regularly that have different pieces of interest, and it's all just walled off. There's no way of doing a coherent coordination between it. There's no tool, no language that I'm aware of that can cross all these boundaries. On my phone, I've come pretty close to throwing it in the street so many times because I have no control over it. It's basically a marketing tool for the corporation. And I really would like one place, so one mainframe, where my whole family stuff, my stuff would all sort of live, and it could just reach out and control these pieces of hardware.
Well, that was what we want. That was what the internet was going to be. That was also what a PDA was going to be. I think Palm marketed something called the Life Drive. It was supposed to magically do that sort of thing. It's a problem. That's an interesting problem, that the day somebody, well,
That's an integration problem.
it's an integration problem, but it's also, you know, you don't just want to have, I think part of what you're talking about is the fact you don't want to just have one device that happens to occasionally function as a TV, and occasionally pull up your websites that you want, and occasionally be a phone that you can actually stop from people
The
calling
same
your-
world visible on any device you want.
The thing that's actually similar between those last two is that they're really data problems, right? The biggest problem with VCR or all these was it didn't know anything about the shows that were on. It knew how to set this, and you had a separate database with your TV guide that only showed you a week of what was going to be on, and you had to coordinate those things. Now, the TiVo, you tell it what show you want. And when it changes, it figures it out. It's integrated all that data. So all the programming data is in one place and it integrates it. You need to use Google Calendar so that everyone can see each other's, can share your calendars and things like that.
Except for the calendar items that you don't want to share.
Except that, yeah, right.
Yes.
I was going to suggest that what we're calling augmented reality might be a disjunctive change. Just things like the Google application where you can point it around and it uses accelerometers and various orientation things to map a display onto where you are. That's kind of interesting, I think, potentially quite useful. And also, can we use that as the motto for DCL 9.0?
It's not the future.
Sorry,
You may use it for whatever you like, but if there's money involved, I want my money. It's, yeah, I mean, and again, it's interesting because we think about these things in terms of modeling, code generation, data integration. And that's what we should be thinking about because that's the stuff that we're doing. We're still dealing with data, we're dealing with data structures, we're dealing with code logic, things like that. But I still have at the back of my head this image of Dan Brickman risking his life as he data reads his